Hello, welcome to section 7.1 where we're going to discuss multiplying and dividing rational expressions. So our goal is first of all to define what it is, figure out the domain, simplify, multiply, and divide rational expressions as well as functions. First of all, what is a rational expression? It's an expression of the form P over Q, where P and Q are polynomials and Q does not equal 0 because you cannot divide by 0. Now, you can see here some examples. Now, how do we determine when a rational expression is undefined? Well, that's because you cannot divide by 0, right? This is a big mathematical no-no. And so what we do to find where each expression is undefined, we let the denominator equal to 0 and solve. So for A, C cannot be 0, okay? Or you can write that undefined at C equals 0 or something like that, okay? So here, 2b plus 5 is equal to 0. We're trying to find out where it's undefined. And then the rational expression for B is undefined at -5/2. So you can also write cannot equal, that's fine too. So here we have the denominator. So we always let the denominator equal to 0 and then solve it. In this case, I'm going to factor x plus 2, x plus 3, right? Because what are the factors of 6 that when added together give me +5? So that's 2 and 3. Zero product property says that each of these factors can be set equal to 0 and solve. So x is undefined. The expression is undefined at x equals -2 and at x equals -3. Okay. Okay, what is a simplified rational expression? A rational expression is considered simplified if there are no common factors in the numerator and denominator. So let's look at this example here. Remember equivalent fractions property that if you have a fraction, a rational number, you can multiply top and bottom by the same thing, and yet you still keep the value. They're equivalent, right? And similarly, if you were to factor a rational expression and then you cancel out the common factor, that's equivalent. So let's say, for example, here, we have here common factors of 3, common factors of 7, and your simplified fraction is 2/5. Here we have 3x times the quantity x minus 9 over 5 times the quantity x minus 9, so the x minus 9s can cancel out. Remember, x cannot be 9 because that would make the denominator equal to 0. And so your simplified fraction would be 3x over 5. In this case, there's no common factor. Even though there's an x, it's not a factor. X plus 5 is the term, okay? So this, while it might be tempting to see something like this and then go, yay, the answer is 1, that's a no-no. Do not do that, okay? All right, so to simplify a rational expression, you just factor both numerator and denominator and cancel out any common factors that you may find. So let's go ahead and get started. So here we have x plus 2, x plus 5, plus 3, sorry. And on the bottom, x plus 2, x plus 6. These x plus 2 cancel. Final answer, x plus 3 over x plus 6. Okay, let's see here. I can factor out at least a common 3, GCF of 3, leaving me with a squared minus 4ab plus 4b squared over, and then here I can factor out a 6, and that's going to leave me with a squared minus 4b squared. That simplifies. 3 goes into 6 twice. So then on the top, that's a perfect square trinomial. So that's a minus 2b quantity squared on the top. And on the bottom, it's 2 from, simplifying. And then this is a difference of squares. So it's a plus 2b, a minus 2b. So this means they have 2 factors of a minus 2b. So I can cancel one of them out. And so final answer is a minus 2b over 2 times a plus 2b. Okay. So one of the properties in a rational expression is the property of opposites. Well, it's any expression really, that the opposite of, so you know how the opposite of 3 is -3, the opposite of 2 is -2, 2, and the opposite of -5 is 5, and so on. Now, if you look at a difference, right, so 1 minus 3, that's going to be -2. What about the other direction, 3 minus 1? That's +2. Let's try another one. 2 minus 5, that equals -3. 5 minus 2 is equal to +3. So you can see that when you're taking the difference, you know, depending on which one's larger, their answer is going to be opposites. Even though it's not commutative, they're not equal to each other, but they are opposites. So if you have a minus b over b minus a, that's equal to -1. An expression and its opposite, they reduce to -1. So let's do an example here. Let's simplify this. So we have x -32. What are two factors of 32 negative that equal -4? So let's think. 8 times 4? -8 times 4. So x minus 8, x plus 4. On the denominator, you have difference of squares. 8 minus x, 8 plus x. Now, using this property here, I noticed that x minus 8 over 8 minus x, all this reduces to become -1. Because you see how it's the same difference except in different order? So that's that. So that becomes negative x plus 4 over 8 plus x, or just 8x plus 8. Okay. What about multiplying rational expressions? To multiply rational expressions, you just multiply across the top, just like how you would regular fractions. But factoring helps because you can reduce and cancel out common factors, okay? So let's go ahead and do that. So here we have 2x over 2 factors of 12, positive 12, that when combined give me -7. That's going to be -3 and -4. So x minus 3, x minus 4, times, this is a difference of squares, x plus 3x minus 3, over 6x squared. Okay, so let's see if we can cancel anything out. We can cancel diagonally as well. So 2 goes into 6 3 times. X cancels out with one of these x's. So final answer, x plus 3 all over 3x times x minus 4. And that's it. Okay, so we just factor, multiply, and you can divide out common factors as well. So step 2 and 3 can be in either order. So let's go ahead and do that. So here we have 3a squared minus 8a minus 3. So that's going to be 3a plus 1, a minus 3. And you can check that if you want to use AC method, you can check that factoring. So a plus 5a minus 5 here times, this is a perfect square trinomial, so that's going to be a plus 5 squared. But I'm just going to write it as 2 factors just so you can see if it cancels out. And then here, this is going to be 3a times a. And then factors of 5 are 5 and 1. So plus 1 minus 5. And that'll give you the correct factoring. So now let's go ahead and cancel out what they have in common. So is there anything in common here? We have a 3a plus 1. And we have an a plus 5 that we can get rid of. Final answer, we have a minus 3 times a plus 5 all over a minus 5 squared. All right. Okay, what about dividing? So when you divide two fractions, it's the same as, how do we do this? We keep, we change, and we flip, right? Keep, change, flip. In other words, you multiply by its reciprocal. So there's a similar thing here. Notice that it's the reciprocal. So dividing is the same as multiplying by the reciprocal. So if we have something like that, let's say we have here p cubed plus q cubed divided by this crazy thing. And then we can multiply. We need to flip this and change it to a multiplication, okay? And factor, of course. Okay, fine. So on the top, this is a sum of 2 cubes, so that factors to p plus q. P squared minus pq plus q squared. Okay, on the bottom, we have here, we can factor out a 2. You get p squared plus 2 plus pq plus q squared. And then times, and we flip this, right? The reciprocal is going to be 6 over, and then difference of squares, that's going to be p plus q, p minus q, sorry. So then let's cancel out what's in common here. The p plus 2's cancel out. Here, 2 goes into 6 3 times. So you have 3 times p squared minus pq plus q squared over p minus q times p squared plus pq plus q squared. Okay, why don't I cancel these two out? Because this is a minus and this is a plus, so I cannot. What if you have something that looks like this? Okay, so if something looks like this, remember that it's equivalent to saying 6. This is a fraction bar. Of course, fraction bars indicate division. Yeah, so you have this over 4x minus 8, which is divided by, and then you have here 2x squared minus 7x plus 3 equals x squared minus 5x plus 6. So you see I've rewritten it into a horizontal division problem. So now we can go ahead and factor, keep, change, flip, right? So let's go ahead and factor this. So you want probably 2x and 3x. And then here we have minus 2 and minus 1. And then all over a GCF of 4, that gives me x minus 2. Now times, and then this is going to go in the numerator now. So that's going to be x minus 2, x minus 3. And then on the denominator, we're going to have to factor this 2x and x. What are the factors of 3 here? We want negative 7 in the middle, so minus 1, minus 3. Okay, and now we can go ahead and cancel out all our common factors. So the 2x minus 1 goes away. These x minus 2 goes away. This x minus 3 goes away. And then what's left over? 3x minus 2 over 4. That's nice. Okay, what about a rational function? What is a rational function? It's basically an expression, except that now you have an equal sign and it has a name. So if we want to know the domain of a rational function, we have to set the denominator equal to 0, solve it, and then the domain is all real numbers except for those that make the denominator equal to 0. So let me show you what I mean. Let's find the domain of this function here. So let's look at the denominator and set that equal to 0. So you get 4x squared minus 16x minus 48, and let's set that equal to 0 to find the domain. I can factor out a 4. That gives me x squared minus 4x minus 12 equal to 0. So divide. I can divide both sides by this 4, get rid of it. So then on the left-hand side, I have x minus 6x plus 2 is equal to 0. So then the two numbers are 6, positive 6, and negative 2, right? So these are not allowed. So they're not allowed in the domain. So the domain of R of x is going to be negative infinity to negative 2, and it's going to stop. We're going to union that with negative 2 to 6, but then we cannot include 6, so then you're going to have to do another union, 6 to infinity. Or you could say all real numbers except x cannot be 6 and x cannot be negative 2. So, all right. So let's go ahead and practice multiplying. So find the rational function r of x when you multiply both f of x and g of x. So let's go ahead and do that. So f of x times g of x is 2x minus 6 over, you know what, I'm going to factor as I'm doing it because to save space. So the 2 times x minus 3, so that's a GCF of 2 on the bottom, x minus 3, x minus 5, and that's times g of x, so this is the difference of squares, x plus 5, x minus 5, and then in the denominator you have a GCF of 2, x plus 5. Let's go ahead and cancel out the common factors, these ones, this guy right here, this one right here, and then finally 2. And then all you're left with is 1. That's interesting. Okay, so I think you guys understand here. So that's it for section 7.1. Oh, your super fun homework is 1 through 69 odd or every other odd. Good luck, happy studying, and I will see you in the next video.